Open your bank statement and find the line that says $20. Then find it again next month and the month after that. Here's what nobody paying that line has been told. The thing you're paying to avoid buying is already sitting in front of you. The laptop you're watching this on can run a model that writes code, reads your documents, looks at your screenshots, and answers with the Wi-Fi switched off. Not a toy version, not a demo. The only thing standing between you and that is knowing which model fits the memory you already own. That's the entire problem. Here's the answer. By the end of this, you'll know three things: the exact amount of memory in your machine, the 4 models built for that amount, and the one line you type tonight to get the first one running. 20 models, 5 machines, find yours. Start with the only number that matters. Not your processor, not your graphics card, your memory. On a Mac, hold option. Click the Apple menu. Choose System Information. On Windows, Control Shift Escape, Performance, Memory. On Linux, type free-h. Now subtract about 4 gigabytes from whatever you just read because your operating system is already using it. And on a Mac, only about 75% gets handed to the graphics side by default. So a 16 gigabyte machine is really a 12 gigabyte machine for this. Write your number down, everything from here is sorted by it. Now the thing almost nobody tells you, and it explains every strange result you've ever seen. The speed a model answers at is not decided by how fast your processor is. It's decided by memory bandwidth divided by the size of the model. Every single word it writes means reading the whole model out of memory again. So a 20 gigabyte model on hardware moving 400 gigabytes a second tops out around 20 words a second. That's arithmetic, not opinion. And it settles the whole Mac versus Nvidia argument. A graphics card moves memory several times faster than a laptop does, but it only holds a little. Apple holds far more and moves it slower. Which one wins depends entirely on the size of what you're running. Tier 1, 8 gigabytes. This is any laptop sold in the last 5 years, and it's the tier people are wrongly told is hopeless. On Mac, that's any M1 or M2 Air, around $500 used. On Windows, you don't need a graphics card at all here. The processor alone will do it. On Linux, same, and a used desktop at $200 runs everything in this tier. Your working budget, about 4 gigabytes. Model 1. Qwen, 3.5, 4 billion. 3.4 gigabytes on disk. This is your everyday model. It answers questions, drafts, and rewrites. And it works across 201 languages with the network of. Model 2, Qwen 3VL, 4 billion. 3.3 gigabytes. This one has eyes. Screenshot an error message, hand it over, ask what's wrong. On an 8 gigabyte laptop. That did not exist at this size 18 months ago. Model 3. LFM 2.5, 8 billion. 5.2 gigabytes and only about 1 billion parameters are awake at a time, which is why it stays quick with no graphics card. Its job is calling tools, searching, running things, chaining steps reliably. Model 4, and this one surprises people. GLMOCR, 2.2 gigabytes. It turns scanned contracts, receipts, and tables into text you can actually search. Its published Omnidoc bench score is 94.62, first place, in 2 gigabytes. Tier 2, 16 gigabytes. This is the mainstream, and it's where running things locally stops being a novelty. On Mac, an M4 or M5 Air, about $1,200. On Windows, the interesting move isn't a new machine, it's a graphics card. An RTX 5060 Ti with 16 gigabytes is about $450. On Linux, the same card and published figures make it the best speed per dollar anywhere in this video. Working budget about 12 gigabytes. Model 5. Qwen 3.5, 9 billion, 6.6 gigabytes. This is the one you leave running all day. It's good enough that you stop opening a browser tab to ask a question. And that habit change is the exact moment the subscription starts feeling optional. Model 6. Qwen 3 VL 8 billion, 6.1 gigabytes. It reads text out of photographs in 32 languages. Point your phone at a page, hand it the image, get the text back. Model 7. Gemma 4 12 billion from Google. 7.6 gigabytes, and it takes 256,000 tokens of context, which means you drop an entire long document in and ask questions about all of it at once. Apache 2.0 licensed as of April. Model 8. DeepSeek R1 14 billion, 9 gigabytes. This is the one that shows it's working. You watch it reason step by step. So when it gets something wrong, you can see exactly where. MIT licensed. Tier 3. 24 gigabytes. Let me be direct. This is the tier where a local model genuinely replaces the thing you're paying for. On Mac, an M4 or M5 Pro around $2,000. On Windows and Linux, here's the value play of this entire video. A used RTX 3090 with 24 gigabytes, around $700. That card is years old, and on everything in this tier, it will beat a $5,000 Mac because it moves memory faster. Working budget about 19 gigabytes. Model 9. gptoss 20 billion. OpenAI's own open model. 14 gigabytes, Apache 2.0, so you can use it commercially. Free. Read that again. OpenAI's model on your machine. Network off. Model 10. Qwen 3.6, 27 billion, 17 gigabytes. This is the all-rounder, the one that stops you reaching for a paid tab. Its published SDE bench verified score is 77.2, higher than most people expect from something running on a laptop. Model 11. Gemma 4 26 billion, 18 gigabytes. Only about 4 billion parameters run for any given word. So you get the knowledge of a 26 billion model at close to the speed of a 4 billion one. Model 12, and this is the headline of the whole video. Qwen 3 Coder 30 billion, 19 gigabytes, 3.3 billion active. Point it at your repository, and it writes code that fits your code base. Instead of generic code, you have to rewrite. 256,000 tokens of context. This is the model that ends the coding subscription. Quick, before tier 4. If you now know your tier and your 4 models, that was the job, and it cost you nothing. Everything here gets checked against the source before it's said out loud. If that's worth something to you, on YouTube, hit join and become a member. On Facebook, subscribe is the supporter button. That's the one that keeps this running. We're on Instagram too. A free subscribe helps just as much. Now, Tier 4. Tier 4, 32 gigabytes. On Mac, an M4 or M5 Max from around $3,200. On Windows, an RTX 5090 with 32 gigabytes. About $2,000 for the card. And published figures put it near 66 words a second on a 30 billion model. On Linux, same card, CUDA native, which starts to matter if you ever go past chatting. Working budget, about 26 gigabytes. Model 13. Gemma 4, 31 billion, 20 gigabytes. This is the strongest single model that still fits inside a laptop, and it handles images as well as text. Model 14. Qwen 3 VL, 32 billion, 21 gigabytes. Hand it a long PDF or a video, and it tells you what happened in it. Not a summary of the first page, the whole thing. Model 15. Qwen 3.5, 35 billion. 24 gigabytes and only 3 billion parameters are awake at a time. 35 billion worth of knowledge. 3 billion running. That's why it fits and still moves. Model 16. Qwen 3.6, 35 billion. Also 24 gigabytes. This is the agentic one. It holds on to its reasoning between steps, so it can work through a long task without losing the thread halfway. Tier 5, 64 gigabytes and up. This is where Apple stops looking expensive and starts being the only option. A MacBook Pro M5 Max with 128 gigabytes is around $3,900. A Mac Studio Ultra with 96 is around 5,300. The NVIDIA equivalent, an RTX Piero 6000 with 96 gigabytes, is 12 to 14,500. Model 17. DeepSeek R1, 70 billion, 43 gigabytes. The deepest reasoning that still fits one machine. Though published figures put it at 10 to 15 words a second on Apple Silicon. That's the honest trade. Model 18. gptoss, 120 billion, 65 gigabytes, Apache 2.0. Frontier class reasoning. You own outright. Model 19. Qwen 3.5, 122 billion, 81 gigabytes, and Model 20. Qwen 3 VL, 235 billion, 143 gigabytes. A maxed out Mac Studio, and the ceiling of what one person can run at a desk. Now the part most videos skip. There's a real ceiling here, and you should know exactly where it sits. The genuinely best open models in the world right now, GLM 5.2, Kimi K 2.6, DeepSeek's newest, need roughly 8 H100 graphics cards, 640 gigabytes of memory. That's a rack, not a desk. Anyone showing you those running at home isn't showing you the whole setup. Qwen 3, Coder's 480 billion version, needs 250 gigabytes just to load. You cannot run these. Not this year. 3 more honest limits. Speed. A 70 billion model on a Mac runs at published figures of 10 to 15 words a second. Slower than you read, and no amount of enthusiasm fixes that. Context. The million token numbers on these spec sheets are real in a lab and not on your laptop, because that context eats the same memory the model is already sitting in. And local is not free, it's prepaid. You buy the hardware once and the electricity forever. That's still cheaper than a subscription for most people. But it isn't zero. And anyone telling you it's zero is selling something. So which machine should you actually buy? The verdict has nothing to do with brands. Below roughly 20 gigabytes of model, NVIDIA wins. And it isn't close. A graphics card moves memory several times faster than a laptop, so anything that fits inside the card runs faster on it. A used 3090 at $700 beats machines costing many times more, right up until the model stops fitting. Above roughly 40 gigabytes, Apple wins because it's the only affordable single device that holds that much at all. An NVIDIA card tops out and stops. Apple's memory is shared, so it keeps going, slowly. The size of what you run picks your platform. The money, as arithmetic, these are assumptions, not a promise. Say you pay $20 a month. A used 3090 costs $700. That's 35 months to break even. Slow. Now say you're on a $200 plan or 3 seats at 20. That same card pays for itself in 3.5 months. And if you're in tier 1 or 2, the honest number is 0. you already own the machine, and the models are free downloads. Add electricity, which is real, and which I won't pretend to quantify for your house. The pattern is simple. The more you currently pay, the faster this stops being a purchase and starts being a refund. Right? Tonight. Step 1, get your number, memory, minus about 4 gigabytes. You already did that. Step 2, install the runner if you haven't. It's called Ollama. One download, all 3 platforms. And I'm not going to spend your time on an install screen. Step 3, pull your tiers model. On 8 gigabytes, type Ollama. Pull Qwen 3.5 colon 4b. On 16, Qwen 3.5 colon 9b on 24. Qwen 3 coder colon 30b on 32. Gemma 4 colon 31b. On 64 and up, gptoss colon 120b, one line. It downloads, it runs. Step 4 is the one that actually removes the bill, and almost nobody covers it. Whatever you already use, your editor, your coding assistant, your writing app, if it lets you set a custom OpenAI endpoint, and most of them do, point it at localhost port 11434/v1. Any API key text works there. It isn't checked. That's it. The app you already use. The same buttons, the same workflow. Except the model is now running on your desk and the meter is off. Then test it properly. Turn your Wi-Fi off and ask it something. If it answers, you're done there. And nothing you type leaves the room again. I put all of it on one page. All 20 models with exact download sizes. The 5 tiers, the buy table for Mac, Windows and Linux with prices, the bandwidth math, the exact pull commands, and the honest limits, so you know what not to expect. Comment the word rig, one word, and my bot sends it straight to you. Free, as always. Real talk. Most of you watching haven't subscribed. On Facebook, subscribe is the supporter button. That's what keeps the lights on here. On YouTube, it's free, and it tells the algorithm to send you more. Subscribe to support us. And if you're just getting started, my step-by-step beginner guides are linked below. Here's what's actually different now. This morning, the AI you use lived in someone else's building, metered by the token, and every word you typed traveled there. Tonight, it lives on hardware you already paid for. It costs nothing per question. It works on a plane, and nothing you write leaves the room. You never needed a better machine. You needed to know which 4 models were built for the one you already have. Comment RIG for the one-page kit. We're on YouTube, Facebook, and Instagram as Hyper Automation Labs. See you in the next one.